right, so welcome. So I'm Kenny Kreitzer. I work for Badger Meter. My coworker Paul wasn't able to attend, but he was a big part of this project as well. And the topic today is the big refactor. Basically, it's kind of our process as a company as we've grown and I guess transitioned and migrating and improving our internal test software. So just a quick overview of what we're going to go through, and we will have time at the end for Q&A, but feel free to stop me at any point if you got any questions. So Badger Meter, we are a very old company. We are a global company. Plenty of people. We've got 5 R&D centers all across the world. We are primarily a water measurement company. That's how we got started as water utilities, the little meters in your house to measure water for the city. But over time, we've greatly expanded our offerings. So instead of I guess kind of in the upper right-hand corner, you can see the brass disc meter. That's basically the simplest meter you got, with a little, basically a magnet in it that spins. There's a little dial on the top that spins. Used to have the meter maid come out and read it off the side of your building, all that kind of stuff. As time went on, we started to get into electronic metering, moving on to the radio endpoints. Older technology was you could build out basically your own radio network within your town, and then the utility didn't have to send anybody to come out to your house. The newer technology is cellular service, so basically you can think of it as like sending a text message over, AT&T, Verizon, T-Mobile, whatever it is that way. Which again, now you don't have to maintain that infrastructure in your own city. You're just relying on what everybody else is using. And then the other kind of further on the right is internal. We offer software as a service to manage kind of like the billing, the status of all the water meters throughout your city, where all those water meters are. We can even actually alert the utility and say, hey, this user has been using a constant stream of water for 24 hours, 48 hours. They probably got a leak. You should probably go out there and take a look. So there are some pretty neat features from the cloud side, but that's not what we're talking about today. Because we are working with the government and utilities, and also us as consumers, you don't want to pay more. You would like to pay less, but you don't want to pay more than the water, more for the water than you're actually using. But the utility would also like to get paid as well. So accuracy is very important. For these endpoints or radios that we have, we do warranty them for 20 years, and we have an incredibly small failure rate over that time. On that 20 years, that is all running on a single non-rechargeable battery, a single battery for the whole 20 years. And you're getting, you can get up to 15 readings, or a reading every 15 minutes. So 4 readings an hour for that 20-year lifespan. So we really have to make sure that our devices are meeting spec in the factory. Otherwise, there's going to be a lot of warranty issues. So again, as we discussed a little bit earlier, the brass meter in the upper left there, if you've got a brass casting and, you're pumping out a lot of those for the houses, maybe you make a small tweak to the casting itself, but really measuring the water for that isn't going to really change much. So your tester didn't have to change. So it was just, very long cycles between updating the test fixtures. Now we're starting to move into something down on the bottom left there that is an electronic meter. It's a water ultrasonic meter. So you got no moving parts, but now you have the ultrasonics you have to deal with. You have the PCBA to deal with, the battery, and all kinds of other complexities that come with it. And now that you have firmware, this communicates to the radio. Obviously, you start getting, possibly field updatable. Just a lot more configuration options than you used to have with just a, we'll say, simple mechanical meter. So this necessitated a change internally with how we tested and designed our test fixtures. So when we first got started, we were a team of 1. Then it became 2, then 3, then 4, and so on. And over the year, you have some turnover, and pretty much it was whatever language you want to use, go for it. And so we had a mixture of all kinds of languages, and lost some source code on some other ones. There wasn't source code control for some of them. So it was we needed to standardize on something. We needed to kind of bring this in a little bit. So one of the first things we did was we ended up implementing LabVIEW. LabVIEW is our standard. We felt that it was a lot easier to create the UIs for the testers. Previous versions, there's, basically command prompt screens, scrolling data through, stuff like that. Now, a lot of our operators on the floor are, they're just loading parts in there, and they're hitting start, and they're expecting a green, a red, pass. They're not technicians that are going to be diagnosing a lot of this stuff. So the programs need to be as simple as possible. LabVIEW just made it a lot easier for us to make that simple for the operator. We also decided that anything new was going to be LabVIEW, and anything that was, say, legacy software would be moved to LabVIEW as the business needed. If we were going to end the life of product in a couple of years, all right, we'll forget about that. But if it's something that we're still going to be using, still going to be building millions of a year, then we go ahead and we're going to start porting that over. We started dabbling in the code reuse with VIPM, using the Pro version so that we could use an internal repository, share code between each other. As we started to grow our team, we were using the project templates, creating your own template that would basically have a shell of a program already, the start of a GUI, start of your sequencer, some database communication, that kind of stuff to hopefully try again to speed things up. Due to some, I guess I'll say, technical debt and historical issues that we had, one of the decisions that we chose was our programs were going to be a monolithic executable, meaning everything got compiled in. If you had to make a change, other than maybe some configuration file settings, it was all in a single executable. I mean, it could be 40 megs, 50 megs, depending on how big, the program was. Now, it could be that it was, several, we'll say, controllers or sequencers based on the number of UUTs. And just for clarity, each one of these boxes is a DQMH module. We decided to go with the DQMH just because it was a little bit simpler for the level of LabVIEW developers that we had within the company. It was just easier for them to understand than some of the other frameworks out there. So what we ended up with was these are examples of a couple different programs that we have. I guess a little shout out to DMC. We do like using their UI controls. I think they look really clean and just like the look. And Badger's theme color is blue, so it does work well with us as well. The problem though is that there's still a lot of custom stuff, even though we got a lot together with the project template. It really just wasn't quite enough in order to quickly roll out changes to programs. And of course, it involved another sequencer, right? Your own homebrew sequencer. Everybody's done one. We did ours. We had some of the same things that a lot of people have. It was a password protected, quote unquote, encrypted file that you couldn't just view in Notepad to make changes. Just the contract manufacturers couldn't be editing stuff to try and take stuff away to make things pass. We had all the standard comparisons like TestStand does, greater than, less than, and all that kind of stuff. One of the nice things was the developer didn't have to worry about formatting results into our internal database format. That's our internal database. Our manufacturing database is pretty restrictive on the data that goes in. It does not like things that are undefined. All your names that you put in already have to be predefined in the database and whatnot. So it's a little bit hard to work with. But this did abstract that away, which was made things a lot easier. The bad, as we all know, is when you're doing your own thing. As far as a sequencer, there's a lot of maintenance. There's when you're trying to roll out updates, you're trying to go back. Okay, well, how many versions back was this person? Do you have one developer who likes to update LabVIEW and their reuse packages once a decade? Do you remember what it was like back, what it looked like back then? Do you somehow have a VI scripting tool that can make the change to go all the way back? You can spend, 3/4 of your week trying to develop scripting tools, trying to figure out how to update stuff from old versions. Really, we did lack some of the features that some of the developers missed from TestStand, which was some of the loops, some of the skipping. I mean, you could do it in there, but it did involve a little bit of customization. That's just, I guess, wasn't as easy as it could have been. So around the time we were doing that, I don't know, this was a year-ish ago. NI kind of started ramping up their NI professional services division again. It wasn't really broadcast too much, but we ended up doing having them do a code review on our systems. What can we reuse that we're currently using, as well as what should we kind of rewrite. We also wanted to get kind of a I guess a smell test or whatever as to what are some of the best practices for working with TestStand. I know that there's many integrators out there. They all kind of have their own flavor. I don't want to say is one better than the other, but they all have different ways of looking at TestStand. But what's some of the gotchas that are out there? And in doing so, they came up with some recommendations. Onboarding was taking longer than desired. Part of that is we could get the developers through LabVIEW 1, Core 1, Core 2, and they're like, okay, I want something more. And so we're like, okay, well, here's our framework, and now it kind of brings in, okay, now you're talking to the database, now you're doing the DUT, now you're doing, and it just kind of seemed to overwhelm them a little bit. And so we were trying to figure out how we could make that a little easier for them. In our area, we're in the Milwaukee area. It's been a little bit hard to find LabVIEW knowledge. There are several colleges in the area, but at the time or recently, most of them haven't seemed to be doing as much LabVIEW in the labs like they used to. So most of the people didn't necessarily have LabVIEW knowledge. However, they had TestStand knowledge. So we could, not necessarily the students coming out of college, but other, we'll say senior people in the area. So we're like, okay, should we really be looking at TestStand? And, as part of this, and wanting to make our systems better, be able to develop faster, we wanted to make sure that we were talking to all our stakeholders, and we meet with our like say our test softwares touch a lot of different departments throughout our facility. Quality engineering, usually that's product quality engineering, but in our company, quality engineering is also the gatekeeper for can we release software to the production floor. So that's why they're required as a stakeholder there. One of the big ones was the operators. Which programs that have we done do they like? What don't they like? What would they like to have? And basically what would make their life easier? So after that, kind of, I guess the summary of the whole professional services review was try to use the standard process models as much as you can. If you're going to use a custom process model, you can, but it can make it harder to upgrade to a different version of TestStand based on depending on the modification that you made. So you may be, stuck at your version of TestStand depending on whatever changes and I made in the back end moving to new versions. PPLs can be very useful. They can be a pain in the butt trying to get to work right and build correctly and all that kind of stuff, but they are very useful in that you get everything in your precompiled package and you don't have to worry about where stuff is on disk, looking for the different dependencies and all that kind of stuff. One of the ones that I guess kind of surprised us was try and make your measurements or the test steps, if you will, reusable and more, I guess I would say, complete in having a, initialize, configure, take the measurement, close, kind of more complete that way versus the, I guess the way we had done a lot of our DQMH modules to communicate with stuff is basically a wrapper for each individual VI that was included with like an instrument driver from like the NI website. Say for a spectrum analyzer, each VI had its own wrapper, if you will, for the DQMH module, where you'd have to make, say, 6 DQMH calls to all the different VIs to take a RF measurement where, maybe it's better to include all 6 of those into a single one that you just call once. And they did show us some of the neat features with Instrument Studio and Measurement Link that you could kind of set up your measurements and port that into TestStand, which based on some of the conversations and presentations today, NI seems to be expanding on that a lot. So that'll be interesting to see in the future. So on the left is kind of where we were at. In the future, we're trying to get to it where the user has significantly less code that they need to do. Basically the process model or the template within the TestStand sequence would handle a lot of all that database communication, the test steps, all that kind of stuff that we commonly do. And it would just be a lot easier to modify your sequence in TestStand than it would be to maybe do a lot of that coding in LabVIEW. All right, so after that, we're like, okay, we've played around with the simple UI. We've played around with the advanced UI that comes with TestStand. And we're like, okay, we couldn't do this ourselves. But is it worth it? There's going to be a lot of, corners we're going to work ourselves into. There's going to be a lot of issues that we're going to work ourselves into if, depending on the design decisions we made. This is our first time going into a TestStand, our LabVIEW-based GUI with TestStand. So we wanted to reach out to some third parties to see if we could work with a partner to kind of jumpstart us and get us there a lot faster. We did get a recommendation to reach out to DQMH consortium because we do use a lot of DQMH modules. And they kind of talked internally, and they sent us to Neosoft, and they thought they would be the best fit for what we wanted to do. And ultimately, after going through a bunch of partners, Neosoft is who we chose as the partner for this. And just so you know, Cyril is on the DQMH consortium. I don't know if you were a part of the decision-making process on picking yourselves, but anyway, even as we had gone through the NI professional services and we had met with several different vendors, requirements gathering, even if you think you have enough detail, you don't. There was just so much, I guess I want to say tribal knowledge that we thought we had written down, and we thought that our vendors and the people we were quoting with understood. But there was a lot of miscommunications on that. And I'm not saying that, we obviously didn't have the best document, if we will. We had 40, 50 pages of it. We tried using flowcharts and stuff like that, but I think those are whole sessions, that you can have on requirements gathering, but really just do spend the time to go through that. It will make things a lot easier. There have been more recently a lot of presentations on some of the new tools, both free and paid out there. I know there's like the AntiDoc. There's also the Chris Cilino has the Atlassian documentation package. Do try and spend some time on some sort of automated method to keep your documentation up to date. It will greatly help you in the long run. Okay. So, previous to this, we hadn't used PPLs very much. That was definitely and is still a learning point for us. One of the nice things is Neosoft did recently release their Teststandifier toolkit. That helps taking the DQMH modules and making them into a PPL to make it easier to work with TestStand. I believe tomorrow Cyril is giving a talk on that. So if you want to learn more on that, feel free to take a look at that. We are currently working through some testing and issues with, say like a factory pattern PPL where we got plugins. Where TestStand really only knows about the abstract interface, and then we can swap out our PPL on disk as needed. That will help significantly with our validation. Again, right now, our code is a complete monolithic executable. So when we go through a validation, a lot of times, you can, through source code, prove that you didn't make changes to certain libraries or whatnot. But with a PPL, you kind of get that extra layer of protection to say, hey, this is the precompiled code. I didn't touch this code. You don't have to look at, this portion of it. So that again will save us on getting our testers, more rapid updates to be able to hit the production floor, because there's not, your validation scope goes down significantly. We did have to do some custom step types. Again, I spoke about there were some requirements of our internal database where the parameter name needs to be defined. Our internal database also does not support the same results as say TestStand. So it only supports pass or fail for every step. It doesn't do the TestStand pass, failed, errored, aborted, and terminated. So basically we had to, in those steps, these are the things that we're going to record to our database instead of trying to parse through the whole giant report and only picking out certain names and then reformatting it and all that kind of stuff. So now the other, hang on, next, So another nice thing about the TestStand is it does allow for multiple report types. So you can save to multiple places. So we can still keep the standard HTML output. If you want to view that, you can, but not everything that's in that HTML report is going to go to our internal database. So this is the UI that we came up with. This is, as it's first open, nobody's logged in yet. We are utilizing the TestStand-based login features and different levels. This one right now is configured to be a 2-up. Let's see here. Here is a single up, and this was a test that ran through and completed. Now, if you notice, the table itself is not the same as the sequence viewer. And that was a design decision that we made. It's not sequence, the execution viewer. Because if it goes through any subsequences or other things like that, it flashes so much going between all of those that if there was a fail in a subsequence, it's just going to real briefly pop up and then it's going to go away. And then at the end, the operator is going to be like, well, I only see passes on the screen. Like, well, why is that? So we decided that we were going to do just our own table and using UI messages to send the specific information there instead of using the built-in execution viewer. It just made it a lot simpler for the operators. There we go. Okay. So in the bottom left there, we have some information on basically what database we're doing, because we can talk to you like a development database or the production database. We have some kind of information on what part number from our internal NES system, and then specific yield information for this device. I think I don't. So in the upper left-hand corner, you can see shop order mode up there. We have about 5 different modes that this can run in. Shop order mode is an internal to Badger mode that has access to our internal MES system. If we're at a contract supplier, they're not going to have that. So then we have a different mode for that, where maybe we pick up the part number from scanning a barcode on the part, or the operator may have to manually pick a part or something like that. But in the shop order mode, as much as possible is taken out of the operator's hands. They just scan the shop order that you're supposed to be running. It gets the parts, it gets all the parameters that it needs from the database. It does all that for them. They just need to load the part and hit start, wait for the green or the red. So the bar along the top, right now, since this is a 1-up UUT, you can see the one green bar above the U. So this is basically, there's 4 tabs there. And because we can go up to 16 UUTs, that was our design decision as our maximum UUTs. And so it'll highlight kind of as the status at the end of the test. So you'll end up seeing kind of like a summary bar, if you will, there of red, green, or hopefully all green up there if you have multiple UUTs, just to make it easier for them to quickly know for the pass fail instead of having to go through each of the different tabs if you had 8, 10, whatever UUTs. There we go. And again, we kind of already talked about this table and our own custom format for that. At the bottom is kind of like a special message area. We can send different messages if we want to inform them about something that's going on in the background, or if there's any errors or anything like that. We can put special information there, and this will kind of resize and shrink based on the number of UUTs. So UUTs, the number of UUTs between 1 and 4 will kind of auto resize. After that, then it's kind of fixed, just because LabVIEW and GUI resizing is fun. So here, you see this is a 2-up. Again, you can see the tables kind of scrunched together a little bit, but we're trying to make the most use of the screen and trying to make it as obvious to the user how did it pass or did it fail. There we go. So there again at the top you can see the green and the red match, the big indicators on the screen. All right, so reporting, again, we briefly talked about this before, but TestStand allows reporting to multiple repositories. Our internal database, we can use our existing DQMH module after it was Teststandified. We did have to make our internal database module be synchronous reporting. The reason for that is through our process, some of the test stations are pretty quickly, the part is pretty quickly moved from one station to the next. So we couldn't necessarily wait for the asynchronous reporting because it's unknown when it's going to get to the database. So we need that data to be in from, say, the PCBA test before the next process is run. Otherwise, it's going to fail the validation that you didn't run the previous process. We have been using Watts, which is a third-party cloud production analytics service. It's been phenomenal to use that one. Watts does provide a TestStand plugin. You just click on there, enable the plugin, and the data just magically appears in Watts. It's really awesome, and we get the true, I would say, HTML-esque report. So we do get a lot more information than we can save to our internal system, which does make it really nice for reporting, trying to troubleshoot it, see where our slowdowns are in our sequences. So now, what does the developer need to do? Well, so the process model and callback overrides are going to take care of most of the setup for you. The developer can really focus now on test and measurements which is what we originally intended and what we want them to do. You get a new spec, you need to do the tests and measurements for that spec. You shouldn't have to worry about, a lot of the framework. We did make the decision to go with a parallel model by default. Obviously, you can run the parallel model with just a single UAT. It's a little bit harder to work with just overall, but it does give us a lot more options versus a batch process, because we do have times where, maybe we have 6 meters that are the same size, and it can be a 10-up, tester. Those other 4, now we can put in different UUTs instead of all of them having to be the same part number or whatnot in a batch. And so based on the GUI that we had, the little table that we had before, we met, pretty much all the requirements that we wanted for this. I will say we're still kind of in the beta stage, release candidate stage right now. But we are seeing a lot of benefits already in being able to kind of spin things up. We can also use, some of those other languages. Still design engineering, when they're doing little utilities at their desk, they might still use Python or C or whatever else they're using. If we can reuse some of those, because now we have TestStand, makes it a little bit easier, that again helps us get to market faster, get to test faster. So it's been a win for us all around. All right. And then I'm at the end. Did I go a little fast? All right. Did anybody have any questions? No.
Oop, there we go. Oh, great. I'm on camera. Just what I wanted. So I had a couple questions, and I'll kick it off with, can you share a little bit more about Watts? I gave myself a note to go by Varenko's booth, and because I noticed that they have some new tooling. And so if you can speak to what you know about what they're doing, because I found several customers using Watts and they really have loved it. So if you can kind of speak to what is Varenko doing with Watts, and then secondly, what is their plan for integrating AI into your test data? Because once you've captured really solid test data, you got your pass fail, you have your variables, then you can, leverage, machine learning and some really simple tools out there to determine what are the variables that are most likely to affect my pass fail.
Yeah. So, I'll be upfront. We investigated both SystemLink and Watts, and for us, SystemLink was price prohibitive at the time. Watts is kind of out of the box. You use their format, and you instantly start getting dashboards. You start getting a lot of tools. Everything's through a really nice web interface UI. SystemLink is going to be a lot better on hardware monitoring than Watts. They're just two different things that way. But with the Watts, you're going to get really good analysis out of the box on like OEE, connection time, execution time, all of that. And it's a really, really simple and well-documented way to send the data to Watts. And they are pretty much every 3 years, they kind of say they rewrite the whole thing and make updates to it. And so it really is constantly evolving. Every quarter they come out with updates, and the pricing on it is really reasonable. Regarding AI, they have started integrating AI into their tool, and basically what it does is it will put up a little like kind of orange triangle, warning triangle that says, hey, you may want to check this measurement. It seems to be not right, and then you can kind of look in there and dig in, and maybe it's a station, maybe it's a nest, maybe it's only a specific measurement, but it'll kind of give you a hint to say, instead of trying to drill down 20 steps, how about you just go look at this one? So it's been pretty neat how they've kind of integrated that in there.
And I have another question, and it's really kind of more a question that several of us in the audience, may want to know. And I know we discussed this back in the day, but could you speak to session management and the fact and how DQMH can manage instrument sessions in such a way that it really it benefits what you guys have as far as being able to stop I'm sorry, I'm not being concise here, but you've got the session management as part of the DQMH module. And when you do a test step that is a full test step, instead of multiple steps, can you speak to the benefits of that design, both the session management and potentially being able to break point and then debug from that perspective?
Sure. So, so the really nice part about the DQMH, especially when you do a clonable module, is you can have multiple instances talking to multiple instruments at the same time. And once you say initialize your connection to an instrument in the DQMH module, I guess you could say keep state. It'll keep access to that instrument, and you don't have to reinitialize that. One of the things that we found was when a lot of our devices, we communicate to it via an IR, serial IR head. And we found that it took 600 milliseconds to initialize that serial port every time. Well, every test cycle, if you can remove 600 milliseconds when you're doing millions of parts, that saves a lot of time. So if you can initialize your instrument, and save it in the module data, and then you just need to make your request. You can check, is it a valid state or not? When you're doing those all-encompassing measurements, it just skips the initialize step and keeps going. But if it hasn't been initialized, it can do that. That saves an incredible amount of time in your test sequence.
I get the benefit of teaching a lot of TestStand to engineers. What's the biggest pain point for you in teaching developers to use TestStand?
To be honest, I'm the TestStand novice on my team.
Oh, very good. What's the biggest
I'm the LabVIEW guy, but I'm the TestStand, I would say more novice on our team. Which is kind of why I was saying it's a lot easier to find TestStand knowledge in our area than it is LabVIEW. But I guess for me, a little bit of the issue with TestStand is just knowing where to look. I mean, it's kind of similar to LabVIEW when you first get started. There's so many buttons and options and places to go for stuff. It's where do you go to do something in there initially to figure that out.
So mostly like navigation and finding how to do what you want to do. You know what to do, but you just don't know how to do it.
Right.
Okay.
And there are many ways to do the same thing in TestStand. You definitely need to define as a team how you're going to do X, Y, or Z, so that you can find if you're debugging somebody else's TestStand sequence, you can find well, it should be in this location, instead of somebody putting it in a station global or, doing something different that way. So
awesome. Thank you.
Hi. A couple points in your presentation. It seemed like you were really cautious not to make any changes to your database schema. Mm-hmm. Is there a reason behind that? I'm just curious.
I don't control it. Test doesn't control it.
Okay.
It is.
So it's like a business.
It's done through an IT group that way. we have been able to, I guess, since we brought Watts on board and we've started doing that, that's allowed us to give more ammunition to internally maybe update our schema a little bit and offer some more stuff. For example, previously we couldn't save like the step execution times or the comparison operator, some of that stuff was just missing. So now it's helping update some of that schema. But unfortunately that's not in our control.
Yeah, makes sense. Thanks.
Yeah.
So it sounds like you guys were kind of flying your existing testing platform as you were developing and moving over to TestStand. Can I get an idea just kind of how big your team was, and then about how long it took to kind of get something like this implemented? Because I'm kind of looking at what I think is a pretty similar scenario in our case of, we've got a pretty small test team, and we're constantly manufacturing all the time, taking up with a lot of maintenance of line activities and things. So making wholesale improvements to it has proven to be quite difficult.
Yep. Yeah. So I mean, say 20 years ago, we were team of one. 10 years ago is when I started at the company. That was a team of two. Probably 8 years ago, we became 3, and now we're up to 6. And so that's kind of how that went. I've been, as a CLA, I've been kind of the architect of the LabVIEW structure, but also, trying to keep up with developing your own internal sequencer, your own internal reuse code, as well as needing to be also a developer and doing systems and whatnot. It gets tough trying to prioritize where you put your time and whatnot, which is why we reached out to third-party vendor. It just made more sense. Basically, we didn't have the resources or the ability to kind of put me on the sideline for 6 months to do my own GUI, versus working with somebody on the outside.
Sure. So I mean, yes. Could you I don't know if you're able to put a timeline on kind of when you started engaging maybe with a third party, person to when you got something that you were able to deploy. Maybe that's a good place to start.
So I would say the timeline would be affected a lot by us internally and us not gathering the requirements correctly or clearly right away, which is kind of why I made a big deal on that one. It took us a year between the NI professional services, finding the party, and getting the released, I guess you would say, UI. You don't necessarily have to go through all those steps. There was a lot of downtime in there. I would say once we did the go, it was 2-3 months, and we had a TestStand UI. So it's pretty quick once you got your requirements there and all that other kind of stuff.
So my question is, do you have a policy on how often you update your framework for the latest version of National Instrument software?
As far as like LabVIEW itself, or?
Both. TestStand. You use TestStand and LabVIEW, right?
Right.
So how often do you update to the latest version for your framework?
So right now, that's not a hard policy right now. Unfortunately, we're working towards, I'll say, a more robust planned upgrade that way. I would see us as probably every other year or every third year doing jumping. Yeah, especially with a lot of the new features that are coming out in 23, 24, whatnot. We have some people who refuse to get off of 2020 and stuff like that. So we're working on getting that newer. But we made the decision to do 2021 as far as the base level for TestStand and the LabVIEW GUI. So they'll at least we'll get them to 21.
Thank you.
were you able to compare like your previous approach in developing a test sequence, I guess, and the new one, and how much efficient are you now versus maybe the old way, or it's too early?
Let's say we don't have final numbers on that yet. That is actively being worked on right now to see, and we're using one of our less experienced LabVIEW developers to do that, to see how quickly can he get up and running with the TestStand sequence using the LabVIEW GUI. But I will say so far, he's going a lot faster than I thought he would be. So,
And I'm kind of following on to that, and I apologize that you may have brought this up in the first 15 minutes that I missed. But speaking to kind of the work that you did with your executive management and having to build out a business model with the numbers to justify the expenditure. So did you cover that in the first 15 at all? Or because I kind of want to hear more about kind of the back and forth of having to set it up, and what were the key things that your executive management wanted to see, and then how are they following through, kind of, for lack of a better term, holding you guys accountable to, this is Kenny, this is what you guys said you're going to do, and we gave you the money, and so what does that process look like maybe today?
So I guess since we haven't, I'll say, officially gone to production with a tester yet, we don't have the final numbers to kind of do that comparison. But how would I say? There was definitely a lot of justification, because you do have to justify your $500 deployment license for TestStand each way, but for each TestStand. But that definitely comes out in the wash very quickly when your board houses are used to TestStand, and you're able to, by utilizing this, I guess I'll say, more standard framework, your ROI becomes a lot quicker by using something that a lot more people have developed, documented, you can ask questions about later. It's, again, I'll say what is it? The rice in the pudding, or what the icing on a cake, or whatever it is going to be once we do the final one and we put the numbers together for that. And that is part of our internal process for what we call a PAR. We do have to go back to the executives and say, hey, we did realize, 3x gain, or hey, actually we got a 10x gain, or we actually lose time, So you got to go back and you do have to report back to executives on that. We are not planning. We do not foresee it as being a negative meeting. We'll put it that way. Well, thank you. Appreciate your time. Thank you.